Do you have a good memory? Personally, I feel like I have a terrible memory. And so as a result, going through school, for example, I've always had to rely on a number of strategies to increase the likelihood of me actually succeeding in school. And one of the reasons I really like this chapter is not only does it explain memory from a psychological and a biological perspective, it also gives us a lot of advice in terms of increasing our own memory. It gives us effective studying strategies, for example. And a lot of the information we cover talks about the average individual. Most likely that refers to people like me and you when it comes to memory. But we're also going to look at very abnormal cases. You will see an example of a man who has an extraordinary photographic memory. And when I say photographic memory, I mean literally the guy, he can remember thousands of details after just seeing them one time. There's a very interesting YouTube video you'll be coming across there. On the flip side, we'll be talking about amnesia, people who have trouble remembering anything at all, and that can be really tragic, and it can actually affect one's life really negatively. All right, so lots of things to unpack here. One definition of memory is presented here for you: persistence of learning over time. And essentially, what we're dealing with is cognitive information that is acquired, stored, and retrieved. Those three aspects of memory are how we're actually going to break apart the entire chapter. And that's our framework. This is a model that was first proposed by Atkinson and Shiffrin in 1968. When they talk about encoding, that's another way of saying acquiring information. So that's step one. Encoding is becoming aware of information. Step two is storing that information. Memory requires us to actually hold on to information for some amount of time. And then finally, retrieval. Memory would be really worthless if we weren't able to actually retrieve that information when we needed it. So this is the three-stage process of memory that we're going to use as a framework for the rest of the module. And what I also want to focus on is something called the information processing model. And what this basically looks at is different general types of memory. So again, kind of three stages here you see on this flow chart: the sensory register, short-term or working memory, and long-term memory. So let's briefly just talk about what's going on here. On the previous slide, you saw the word encoding, and that's pretty much what's going on here. The sensory register is the input. In other words, we use one of our five senses: touch, taste, hearing, vision, smelling. We use one of those to become aware of information. And at any one time, we are aware of billions of bits of information. But obviously, we can't pay attention to all of that information. Visually speaking, for example, when we look around our visual field, we are seeing tons and tons of details. If I look around me, I'm seeing colors and shapes and lines. But if I were to close my eyes and think about all of those details, I wouldn't be able to remember all of them. And the bigger issue is that I'm not paying attention to all of those details unless they're really important. And the reason for that is because my second stage, known as short-term memory or working memory, it is really limited. As we're going to talk about, and as you'll see in the chapter, psychologists pretty much argue that our working memory is limited to about 7 pieces of information, plus or minus 2. So somewhere between 5 and 9 pieces of information can be actively processed at any one time. And so again, if I look around, I'm seeing tons and tons of information, but most of that information goes away because I can't hold on to it long enough. Importantly, from an evolutionary perspective, I'm only going to pay attention to the things that I think are really worth my limited attention span. So if there's something that I think would benefit me or even harm me, I need to pay attention to those things. And unfortunately, that means that a lot of information gets ignored. The information that is worked with enough or actively processed enough, that can get stored in our long-term memory system. And theoretically, long-term memory, it's permanent and it's unlimited. But just because something is in our long-term memory doesn't mean we can retrieve it. And so that's what you see with this arrow here. Retrieval refers to the idea of actively getting information from the long-term memory stage and bringing it back to our active consciousness. In other words, the working memory stage. Think about like the tip of the tongue phenomenon. Have you ever experienced that time where maybe you're trying to think of somebody's name and you know their name, but you're drawing a blank. It's like at the tip of your tongue. We call that a retrieval failure. There's something blocking you from getting that information from long-term to working memory. All right, the last thing you see down here is the central executive. And this is just to point out that we, as conscious beings, are in charge of the flow of information, at least from a conscious standpoint. From a subconscious standpoint, there's a lot of other influences that affect our memory system. But what this is getting at is we control what we deem important in terms of what to pay attention to and what to ignore. When I look around my visual field or when I hear my auditory field, all the information coming at me, it's too much to handle. I can't remember it all. The average person has a limited memory span, and for that reason, it's the central executive that has to pick and choose what might be important. Okay, so there's a couple other things I want to focus on in this introductory video. And this next idea requires us to look at this demonstration here where you see 6 different pennies. But one of them is real and the rest are just, they're photoshopped to have an incorrect layout. So one of the things I think is important here to think about is that what we remember depends on a number of factors. A penny, for example, is something that we come across all the time. I mean, you may have handled a penny thousands of times in your life, but the majority of people will not be able to identify this penny correctly, at least without some help. All right, so take a look at it, see if you can identify it. And the real penny is the one on the top left. It's this one right here, I think. So what does that tell us? That tells us that what influences what we remember is not necessarily how many times we do something, but how we process it. And when it comes to processing, think of memory processing in terms of different levels. We can process information at a shallow level, like we might with a penny, or a deep level, or a more meaningful level. So for example, when you hold a penny, you probably don't stare at it. You probably don't try to memorize what it looks like. Somebody may have given you that penny. Maybe you took it real quick, you put it in your pocket, and then you took it out of your pocket when you needed to pay for something. So you process that information at a very shallow level, even though that's a process that might have happened many, many times over your life. So let's look at a different example. And in this example, I'm going to describe a series of steps, and it's your job to try to remember these steps in as much detail as possible. All right, so I'm going to read the story to you. If you want, you can pause it and try to write down as much detail as possible to see how you did. All right, so here it goes. The procedure is actually quite simple. First, you arrange things into different groups. Of course, one pile may be sufficient depending on how much there is to do. After the procedure is completed, one arranges the materials into different groups again. Then they can be put into their appropriate places. Eventually, they will be used once more and the whole cycle will then have to be repeated. However, that is part of life. All right, so pause the video if you want and just think about, how much of what I just said do you recall? How much can you retrieve from your memory system? Now, when people do activities like this, most people don't remember a lot of that information with a lot of good detail. And the reason is because the story I just described was extremely vague. It was really general, and as a result, you probably processed that information at a shallow level. But on the other hand, researchers can take that exact same series of steps and just give a little bit of context. Specifically, if I told you that these are the steps involved in laundry, washing your clothes, doing your laundry, if I were to tell you the exact same procedure again, you could recall a lot more detail. So, for example, think of laundry. The procedure is actually quite simple. First, you arrange things into different groups. Of course, one pile may be sufficient depending on how much there is to do. Yada, yada, yada. All right, so I'm not going to do the entire thing, but what happens here is when we think about that exact same procedure with the context of laundry, it allows us to process that information at a deeper level. And that is actually using something called the self-reference effect. The self-referencing effect is where we take incoming information and try to relate it to something that we already know about. Because if I can relate incoming information to what I already know, I'm going to be able to process that information at a much deeper level. It'll be organized in my cognitive processing system much better, and therefore that increases the likelihood of remembering information later. Okay, so what we were just getting at is the way we encode information drastically affects the likelihood of storing information and therefore retrieving information later on. So again, this is the three-stage processing model of memory, and we're going to detail each of these as you move forward.